Hey everyone, on the next application of integration, I'm going to take you back to the introduction to integration, where we establish that integration is basically the method of finding the area underneath a graph from two specific points, right? So let's have a point from A to B. And the idea is that if I have infinite number of rectangles of very small width, or delta x or dx, then I would be able to get the area of the curve that's underneath, area underneath the curve between the x-axis, right? And therefore we establish that from here it's just a, b, and let's say the function is just fx, dx would yield us the area underneath the curve and bounded by the x-axis. So that is where we get the proper application of integration. We used to find or compute the area through integration, and more specifically definite integrals. All right, so let's use a very quick example integrating the function x dx. Let's say I want to find, the question asks you the area, find the area of the graph between x equals to 1 and x equals to 2. And the graph happens to be fx, y equals to x, right? So again, we draw the graph, right? So we know that y equals to x is basically a straight line through the origin, so it's a linear graph. And what we notice is that the area, area has to be positive, right? So the area is above the x-axis, right? So this, let's say this is 1 and then this is 2. What we notice is that the area is above the x-axis, so this area is what we want to find. So we don't have to do much actually. It just, simply perform your definite integral, which is basically x squared over 2 with my upper limit 2, lower limit 1, I will get 3 over 2. All right. If you watch the previous video, you'll notice how I get the answer. Otherwise, I'll just write it here. So first you sub in 2, you get 2 squared over 2. Then you must put a minus sign. Then minus, sub in 1 now, so you get 1 over 2 to give me 3 over 2. So because they're asking to find the area, you must put the units, right? Which is, in this case, units square. Now let's say what happens is that if you notice from the area in the negative x direction, so in the negative x values, you notice that the area between the graph and the x-axis, they are below the x-axis, right? Because they're below the x-axis, these areas are actually computed as negative values. To prove this, let's say I have, a specific example, let's say I have minus 2 to 0, right? And again, I have x again. What you'll see is that I'll get x squared over 2, right? As per usual, do your normal integration. Now I sub in the upper limit 0, and I'll get 0 squared, so, it's just 0. Minus away, minus 2 squared over 2, which will give me minus 2 units squared. And because area can't be negative, we have to do something to it, right? So there are a few ways to do it. So when you want to compute negative areas, so for negative areas, right? For negative areas, let's say the negative areas between, for some a and to b, and then you're integrating some function. What you do is a few methods to do it. First, you put a modular sign. So you put a modular sign, which works exactly the same because modular sign means that you want the absolute value. Another way is that you put a negative sign in front, and obviously that will give you back the positive value, right? If integrating b to a, integrating a to b is negative, you'll get a negative, you get a positive value at the end. Alternatively, if you are very sure that from a to b is completely negative, so let's say from here you have minus 2 to 0 is completely negative, you can actually put the limits in the other way around. So instead of integrating from a to b, you integrate from b to a, which will give you back the same answer, just that it's in the positive value. All right. So to give you even more examples, let's say I have integrating sin x from pi to 3 pi over 2. All right. So one look, so if you know your sine graph really well, you know it's something like this, right? This is pi, and from pi to 2 pi it's negative, right? So you get a negative area from pi to 2 pi. You're integrating from pi to 3 pi over 2, so whatever area you have from pi to 3 pi over 2 is gonna be negative. So what I'll do is, if I know that the area is negative from here, what I prefer to do is just simply, well, I just invert the limits. And these completely allowed, right? You just perform the same idea, right? So integrating sine x will give me minus cosine x. Then I'll put the limits as I put earlier. So if I have pi on top, pi will be on top. If I have 3 pi over 2 on the bottom, I'll have 3 pi over 2 in the bottom. Next, I'll just minus cosine pi. So minus become plus, so do be careful with this. Cosine 3 pi over 2. So minus cosine pi is basically minus 1, so I get positive 1. Cosine 3 pi over 2 is basically 0, right? So the area is simply 1. So there's nothing much to it. This is just basically the basics of your integration to find the area. Now what happens is, if you go back to this graph, right? Let's just use sine x as say example. What happens if, okay, now find the area from 0 to 3 pi over 2. Okay, now it's kind of different, right? Because you have a mix of positive area here and negative area here, right? So obviously, if you're going to integrate them together, you'll get the positive area minus away the negative area, right? Which is not what you want, because that will give you a even smaller area than reality. So what you do is, actually, if the question asks you for the area, you must split them up, all right? So first you split them up when the area is positive and the area is negative. So if you look at the graph, right, the area is positive from 0 to pi, so you integrate from 0 to pi sine x. Then you integrate from pi to 3 pi over 2, the area is negative, so you can immediately write this down. So you can immediately write it as plus 3 pi, integrating from 3 pi over 2 to pi sine x. All right, this would be what I would do. Obviously, you can also write it as, so on top, minus away pi to 3 pi over 2, alternatively plus mod of pi 3 pi over 2 sine x. All right, anything goes, right? Really, anything goes. So it's completely up to you. But whatever the case it is, right? So from 0 to pi, it's basically minus cosine x from 0 to pi plus, as you worked it out just now, 1. So minus cosine pi is basically minus 1, so it's 1. Plus cosine 0, which is another 1, then I plus another 1, so this will give me back 3. Again, missing my units. So 3 unit square, I miss 1 here as well, so 1 unit square. Alright, so this is the introduction to finding the area between the curve and the x-axis.